Okay, welcome back to the lecture 6 of motion. Now, in the last lecture, we were solving the numericals, so I thought that I should continue from there only to reduce the confusion, right? So, we were discussing this question and we solved this question, we got the answer and everything. We used this equation of motion, right? So, now we have the next question, right? So a motorboat starting, so the next question is the motorboat starting from rest accelerates in a straight line at a constant 3.0 meter per second square for 8 seconds. Okay. So the acceleration time is, so the acceleration here is 3.0 meter per second square. Okay. And the acceleration happened for 8 seconds. That means there was a change in velocity for 8 seconds. Okay. Now, how far does the boat travel during this time? Okay, so we have to find out that how far does the boat travel, right? So we can use this formula here using the second equation of motion. S is equal to ut plus half at square. And because the motorboat was starting from rest, because it was starting from rest, so the initial velocity becomes 0. So you need just two things now, acceleration and time. So just take a look. Initially it was at rest, acceleration was given 3 meter per second square, time is 8 seconds, right? So you just need to find out the distance. So for distance you can use this initial velocity 0 meter per second, acceleration is a, that is 3 meter per second square, time is 8 seconds. So to find distance covered, we can use this formula. This is very simple, right? So just check out the formula. They are using the second equation of motion. So just put the formula and put the values in the formula, so you will get the distance covered here. See, ut plus half at square, u0 into t8 plus half into 3 into 8 square. So simply just solve it. Half into 3 into 8 square, that is half into 3 into 64. Simplify it and then you will get the distance covered, that is 96 meter. Now I have already told you that you can use this very simple formula, that is S is equal to ut plus half at square. Okay. Now this was the easy one. Let's come to the next topic, and the last topic of motion in one dimension is that circular motion, right? Now initially whatever we were studying, that was based on the particle or the body moving in a straight line. Okay. Here also, or in motion in class 9, what we discuss is that the particle is moving in one dimensional motion, right? So we're going to discuss another type of motion called uniform circular motion. Why we are calling it as a uniform circular motion? Because the speed here of the particle is not changing. It will move with a uniform speed. Now you must be thinking that why uniform speed, why not uniform velocity? So we'll discuss it. Like, let me just start with the topic and then you will get to know that why we are not saying that the particle is moving with a uniform velocity, why we are only saying that the particle is moving with a uniform speed, right? Just because the particle is moving in the uniform speed, that is why we call it as uniform circular motion. Though in NCRT there is a statement given called that in uniform circular motion the particle is under the acceleration, that particle is going under the acceleration, right? Now sometimes what happens, that when we study or when we think that if the speed is constant, how come that we can say that it is an accelerated motion? How is that possible to say that it is an accelerated motion? So this is the things that we're gonna discuss in this lecture, and this is, in every lecture what I feel is that every lecture is important in one or the other way. But uniform circular motion, when we go to class 11th, right? So we're gonna deal with more types of motion, or more in depth we can say. So there many students face big problem in circular motion because the basics are not very clear. So when I'm saying that, again I will say that the lecture is very important, because this is the topic which can either make the basics very clear or it can create a big problem in class 11. So you decide. Okay, that whether you want your basics to be really clear, and you should have that idea that okay, this is the difference between a circular motion and uniform circular motion, and horizontal circular motion and non-uniform circular motion and vertical circular motion. There are so many types, but we're going to discuss a particular type where we are saying that the particle is moving in a circular path. Okay, its speed is constant. Next point. But then also we will say that the particle is under constant acceleration. So what is constant acceleration, and what type of force is required to keep the particle in circular path? This is the topics that we're going to discuss. Okay, so let's start with the uniform circular motion, right? So suppose, like, we consider a closed path. Let's start with the closed path, right? Here the particle is moving in a closed path. Okay, its velocity is continuously changing. Now similarly, just take a look. Here the particle is moving in a rectangular path and it is a closed one. Okay, for the another we have taken a pentagon, right? Here also it is continuously changing. For hexagon, it is also a closed path and the velocity of the particle is continuously changing, but for certain time, right? But in uniform circular motion, the particle has to travel in a circular path. So whenever a particle is traveling in a circular path, we call it as circular motion. Okay, so what is circular motion? Circular motion is the motion of an object along the circumference of the circle, right? If the particle is moving in the circular path or along the circumference of the circle, then what we can say, that the particle is performing circular motion. Now what is uniform? See, first we discuss about the circular motion. What is circular motion? When the particle is moving in the circular path. Now what is the big difference between a circular motion and uniform circular motion? Basically it is one more condition. It is one more condition, that okay, if the particle is moving in a circular path and also it is moving with a constant speed. Whenever I will mention uniform circular motion, I will always say constant speed, not constant velocity. Remember, if I start to say that it is moving with a constant velocity, then my statement is definitely wrong. I can never say. Because in uniform circular motion, if we are mentioning that okay, the particle is under uniform circular motion, then one thing is very sure, that the speed is constant but not the velocity. So you have to memorize this. You have to, I'm brainstorming this topic, I'm brainstorming this point to you, so that you remember that our sir said ki yes, it can be constant speed when it comes to uniform circular motion, but it can never be constant velocity. Got my point? So it will never be constant velocity, never, because velocity is continuously changing. Now again there a point will come that sir, speed is constant but velocity is continuously changing. So this is two statements which are not directly correct to each other. If a particle is moving with a constant speed, sir, then how come we can say sorry, how come we can say that particle the velocity is continuously changing? See, let's get back to the basic. Think for once, if I say that a particular object was traveling with a speed of 10 km per hour, right? Okay, but if I say that it is traveling in the direction of east, so this is now velocity, because it has magnitude as well as direction, right? Now I give another statement. This is body A. This is body A. Okay. Now when I take another body which is moving, suppose B body, which is moving with some velocity that is 10 km per hour, but it has a different direction. say north. So one body is going in east direction, right? One body is in east direction and other body is in north direction, right? Hello beta. So if direction are different, the velocities are different, that means we got one idea that okay, VA is not equal to VB. Getting my point? Why we are saying that VA is not equal to VB? Because it is not dependent on the magnitude only. It is also dependent on the direction. Yes or no? So if the direction are different, we can say that velocities are different. But we can definitely say that speed of object A is equal to the speed of object B, right? So speed A is equal to speed B. Yes or no? That means velocity can change according to the direction, but speed is only dependent on the magnitude. Yes or no? Okay. Now think. So whenever I am saying that under uniform circular motion, the speed is constant but velocity is not constant, that means the magnitude of the velocity is not changing, but direction of the particle is continuously changing. Just take a look, right? If you draw velocity at any instant, just think, if I draw the velocity, direction is like this. If I draw the velocity here, direction is like this. If I draw the velocity here, direction is like this. If I draw the velocity here, direction is like this. If I draw the velocity here, direction is like this. So at every point, the velocity is tangential. You getting my point? Velocity is tangential. That means the direction of the velocity is changing, but not the magnitude. Okay, so if the magnitude is not changing, like suppose at this point, just take a look at this point. Here also velocity is different. Whenever I am saying that velocity is different, yes beta, we will definitely gonna teach class 9th ICSE as well. Okay, we have just started. So once this motion chapter is complete, then we'll come to the next topic, that is force and laws of motion. In that I'll be discussing little bit extra, so that will help in your ICSE as well. Okay, right. So whenever I am saying that in a uniform circular motion the speed is constant but velocity is not, so because you should know, for the particle to move under circular motion or uniform circular motion, its speed only has to be constant. Velocity cannot be constant, because at every instant, the direction of the velocity is changing. Now because the direction of the velocity is changing, so we can simply say that velocity is changing. And whenever velocity is changing, we can say that it is an accelerated motion. But this acceleration is not changing the magnitude of the velocity. This acceleration is only changing the direction of the particle. Okay, this acceleration we call it as centripetal acceleration. Centripetal acceleration. Centripetal acceleration. So when we talk about centripetal acceleration, here what this centripetal acceleration is doing, this centripetal acceleration is just responsible for changing the direction of the velocity, not the magnitude. Okay, and this acceleration is acting towards the center, that is why we call it as centripetal acceleration. Got my point? Okay, so this, what does this centripetal acceleration doing? Remember that this centripetal acceleration will change the direction of the velocity. Will change the direction of the velocity. Are yes or no? So remember, whenever we talk about uniform circular motion, in uniform circular motion, the particle is exhibiting its motion under the circular path, or it is along the circumference of the circle. Okay, for uniform circular motion, why we are calling it as a uniform circular motion? Because speed is constant. Okay, constant speed. But don't get confused that if speed is constant, velocity is also constant. No, velocity is not constant. Velocity is variable. How come velocity is variable? Because at every point the direction of the particle is continuously changing. Because direction of the particle is continuously changing, that means we can say that velocity is changing. If velocity is changing, that means we can say there is an acceleration, and that acceleration is called as centripetal acceleration, and that centripetal acceleration is only responsible for changing the direction, not the magnitude. So I hope that till here it is clear, then we can proceed. Okay, right. Now, so anyways, we need to mention, if I need to find out the velocity, if I need to find out the speed, so what is the circumference here? Like if the radius, say it is r, right? So the radius is r, and if the body takes t second, total time taken by the particle to complete one round is t second. Okay, right? If v is the speed, why we are finding out the speed? Because we cannot mention the velocity, because it is continuously changing. So speed is what? Distance upon time. Here distance is the circumference of the circle. Speed is what? Distance upon time. And distance covered by the particle is along the circumference, right? So if distance covered by the particle is along the circumference of the circle, so circumference of the circle is what? 2 pi r, right? 2 pi r by t. So this is how you find out the speed of the particle under circular motion. How you find out the speed of the particle under circular motion? Speed is equal to, or v is equal to 2 pi r by t. Here pi is either taken, you can put the value 22 by 7 if it is not given in the question that what value you have to take, or anyways the value is constant here, it is not changing, but sometimes in the numerical they tell you that whether you have to take 22 by 7 or whether you have to take 3.14. Okay, so if it is not given, you should take 22 by 7, because 3.14 is the rounded off, because 3, when you divide 22 by 7 na, so it is a reoccurring, like you must have studied in maths, so the values are reoccurring here. So it has basically the bar above, like 1 4, because it is reoccurring, no? So it is better to take 22 by 7 when you are not given with any values. Okay, when you are not given with any values, you just, what you can do, you can put the value 22 by 7 of pi. But in some numericals they ask you to take, to make sure that the solution of the question is easy, right? To make the easy solution, they ask you to take the value 3.14. But again I am saying, if we have to follow the rules, if we go mathematically and what physics says, then you should only follow pi is equal to 22 by 7. Okay, but sometimes, again I am saying, sometimes they ask you to take 3.14, because mathematical values get easier when you put 3.14. Okay, so speed of the particle here can be taken out by the circumference of the circle upon time taken. If the time taken is t, like suppose, like let me give you one example here. Like suppose we have radius r is equal to, say, 7 centimeter. Okay, r is 7 centimeter. Then, and I can take, say, time taken completed to taken by the particle to complete one round is, say, 10 seconds. So if I ask you the speed, okay, so you can go with a very simple approach. Speed is equal to 2 pi r by t. Okay, so time here is how much? 10 seconds. Radius is how much? 7 centimeter, and pi will take what? 22 by 7, right? So speed is equal to 2 into 22 by 7 into 7. Radius is 7, no? Right? Upon 10 total time. So you can cancel this out. You get 44 by 10, which is 4.4. Here the radius is in centimeter I have taken. No. So the answer is 4.4 centimeter per second. Okay. So this is how we can solve. We can find out the speed. No worries. Okay. Got it? Is it clear? Right. Let's go ahead. Numerical based on, like, this is a very small topic, right? So we'll do just 2-3 questions, and anyways, like in NCERT it is given in one paragraph. So I have told you everything whatever is required in the circular motion, because it is very limited, can't help it. So whatever is needed, like you need to remember in circular motion, there are certain things which you need to remember. Particle is under constant speed, that is why we call it as uniform circular motion. Okay, not constant velocity. It is constant speed, not constant velocity. Okay. Then it is an accelerated motion. What type of acceleration it is? We call it as centripetal acceleration. Is this acceleration responsible for changing the velocity? Yes. Is this centripetal acceleration changing the magnitude of the velocity? No. Then what this acceleration is exactly doing? Just changing the direction. Direction of the particle. Okay. Direction of the particle. What my point? Direction of the particle. Okay, so this is all about the circular motion, or we can say uniform circular motion. Everything I have taught you which is required in this class 9, you need not to worry. Anyways, it is, very small paragraph given in the last, but this is all of it which is required till class 9. When you will come to class 11, I will teach you more. Don't worry about it. Okay, now let us solve certain numericals which are, somehow important in the school level examination. So this is my one of the favorite topic, numerical based on average speed and average velocity, right? So we have already discussed average speed and average velocity. So this is one question, that odometer of the car reads 200 km at the start, right? So this is the reading of the odometer. Now odometer is basically a device which reads the distance traveled by the car. Okay, so there are many students who don't know what odometer or speedometer. Speedometer is what? Which tells the speed. Odometer which tells the distance. Okay, so the odometer of a car reads 200 km at the start of a trip and 2400 km at the end of the trip. So total distance traveled, anyways, it's 2400 minus 2000, because initial odometer reading was 2000 and then final odometer reading was 2400. So 400 is the distance traveled. Okay, this is the very basic thing. If the trip took 8 hours, calculate the average speed of the car in kilometer per hour. Okay, so what we can do is, so average speed is what? Total distance upon total time, right? What is total distance here? 400. What is total time here? 8 hours, right? So we are moving with 50 km per hour. So this is the average, right? This is the average speed of the car in kilometer per hour. So this is 50 kilometer per hour. And if you want to change this 50 kilometer per hour into meter per second, just multiply it by 5 by 18. What my point? Okay, let's just check. So there is a car, initial odometer is 2000, then final is 2400. Okay, initial odometer reading given to 2000, final 2400, time is 8 hours. Average speed, average velocity, what is the formula? Total distance upon total time. Distance covered is change in the odometer reading, right? So final odometer reading is 2400, so 2400 minus 2000, right? So the distance covered is 400 kilometer. Now average speed is what? Distance upon time. So 400 upon 8, it is 50 km per hour. So this is the velocity that we already solved, right? 50 km per hour in Then we can find out in meter per second. So just multiply it by 5 by 18. They have like used a simpler method, but we have already discussed it directly, right? So 50 into 5 by 18, that is now, so 50 kilometer per hour is average speed, and if we talk about in meter per second, so it is 5 by 18, sorry, 5, we multiplied by 5 by 18, then it is 13.9 meter per second after solving, right? So 13.9 meter per second. Again the average speed. This is same average speed only, just in the different units. Okay. Now coming to the next question. So Abdul, while driving to the school, computes the average speed for his trip to be 20 km per hour. On his return along the same route, there is less traffic and the average speed is 40 km per hour. What is the average speed for Abdul's trip? Now, listen to me very carefully. What happens, like this type of question you can see in the NCERT also. What happens, like suppose many children get confused. So say this is home and this is school, okay, and this is school and this is home. So here you need to remember one thing, that distance between home and school is anyways constant. No, if Abdul is traveling say d distance from home to school, then it will also come back d distance only, na? Yes or no? Right? So what happens, I have seen many students doing this mistake. What they do, they just add 20, what is the other one, 40 by 2, because average speed already given, so 30 is the answer. No, this is wrong. This is not the correct way to solve average speed and average velocity, right? The correct way to solve average speed and average velocity is total distance upon total time. That's it. No other method has to be followed. Okay, getting my point? So total distance upon total time, when we talk about total distance, so total distance is again 2d. For this distance, the speed was 20 kilometer per hour, right? So we can find out the time here. Okay, and for this distance it was 40 kilometer per hour, so we can still find out the time here. So suppose this is t1, this is t2. Okay, so what I can exactly write, I can simply write 20 is equal to d by t1, correct? So t1 comes out to be d by 20. Similarly here t2 comes out to be d by 40. What is the formula for average speed? Total distance upon total time. Total distance is 2d, total time is t1 plus t2. So when we talk about t1 plus t2, total distance is 2d, total time is d upon 20 plus d upon 40. So you can solve this, right? Take d common, it will get solved, it will get cancelled. So 2 upon 1 by 20 plus 1 by 40. Now you can take the LCM and you can further solve it. Let's check. So we have the animation, they have taken x kilometer, then coming back x kilometer, the same way we have only taken d and d. Okay, so now given distance covered is 2x, average speed is 20 km per hour. For another, average speed is 40 km per hour. Same method, distance covered upon time taken. So time taken is 20, we will find out the time here. So x by 20 r, right? This is what we did already. Then x by 40. Okay, so for whole trip we solved, and then eventually we'll get 80 by 3, that is 26.67. Okay, so when you will solve this, eventually you'll get this value only, 1 by 2 upon 1 by 20 plus 1 by 40. Okay, so it will become now 60 by 800 if you take the LCM. So if it will become 60 by 800, then 6 by 80, 80 will go in the numerator, so 2 into 80 is 160, 160 by 6 is 80 by 3. So the average is coming out to be 26.67 kilometer per hour, but eventually some student try to solve this directly. Ki, okay, 20 plus 40 by 2, which is equal to 30 kilometer per hour, which is purely wrong. You cannot do this at all. Average speed, you cannot find out this way. For average speed, you have to follow this basic step called total distance upon total time. That's it. Now you have the speed, you have the distance, you can find out the time, and then you can further solve. Okay, coming to the next question. Right. So Joseph jogs from one end A to the other end B, a straight 300-meter road in 2 minutes 50 seconds. Okay. Then, so let us take A point and let us take another B point. Okay, A to B. So it is 300-meter road, and it took him 2 minutes 50 seconds. Right? So if I convert this into seconds, it can be written as 170 seconds. Got my point? 170 seconds. Clear? And then he turns around and comes back 100 meter to point C in another 1 meter. So 1 minute. So he took another 60 seconds to come back. Right? So we have to find out the average speed and average velocity. Now listen to me very carefully. For average speed, it is total distance by total time. Okay, average speed is total distance upon total time. What about average velocity? It is total displacement, or we can say net displacement upon total time, right? So while solving average speed, total distance, see, he traveled 300 meter and then he traveled more 100 meters. So the total distance is 400 meter, right? Then total time, it was 2 minutes 50 seconds and then 1 minute more. So the total time which is coming is 300 plus 100 is the distance. Total time in seconds. So 170 seconds plus 60 seconds is 230. So 400 by 230 is 40 by 23. Right? So this is the average speed that we're talking about, 40 by 23. Okay? And this is in meter per second. You are given the time here in minute, but we are finding the answer in meter per second. Getting my point? Okay. Now, when it comes to velocity, okay, now listen to me very carefully. When it comes to velocity, now Joseph is exactly standing at point C, which is just 200 meter. So the net displacement comes out to be 200 meter, whereas the distance was 400 meter. Okay. So for average velocity, total displacement is 200. Total time, anyways, time is gonna increase, right? So time is 2 minutes 50 seconds plus 60 seconds, that is again 230 seconds. Getting my point? 170 plus 60. So average velocity is coming out to be 20 by 23. Getting my point? So average speed and average velocity gonna come different, because one is distance upon time and other is the velocity upon, displacement upon time. So distance and displacement, because the particle here or the person here is not moving along the straight line, but it is coming back, right? So the distance and displacement are different for both the cases. So therefore you are getting different answers. Remember, time will always increase. Time is never gonna reduce. Okay. So for one, when we are solving for average speed, it will be total distance upon total time. And for average velocity, it will be total displacement upon total time. Getting my point? Okay. Now, coming to the next question. This we have already done. Right, so the final answer, I just wanted to make sure that you get the final answer. When we talk about the final answer, see the average speed A to B, it was 40 by 23. You people can solve. So 40 by 23 is coming 1.765 meter per second. But whereas when we talk about the average velocity, it is 0.87 meter per second. So the average velocity and average speed gonna come different. Okay, got my point? Right. So now we'll be discussing, we have discussed about the average speed and average velocity. Now the next type of numerical that we're going to discuss is based on the acceleration. Acceleration is equal to v minus u by t. And also we'll be discussing about the equation of motion. Right? So the first question is, a car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. Calculate the acceleration and distance covered. So now, first of all, we can simply, we have the initial velocity, we have the final velocity, but the problem is that these speed is given in kilometer per hour. So what we are going to do is, we're going to change this kilometer per hour into meter per second, right? So what can we write exactly for 18 kilometer per hour? 18 kilometer per hour converted to meter per second. How? Multiplied by 5 by 18. So initial velocity is 5 meter per second, right? Similarly, final velocity into 5 by 18, 18 to 5. So final velocity is coming out to be 10 meter per second. Now we have the time taken is 5 seconds, so we can simply find out the acceleration. Okay, acceleration is equal to v minus u by t. Acceleration, what is the final velocity here? 10 meter per second, right? So 10 minus 5 by 5. Simple. Just use what? 10 minus 5 is 5 by 5. That is 1 meter per second square. Got my point? So the acceleration of the particle here is 1 meter per second square. Okay. Now coming to the distance covered. Here we can use the equation of motion. Equation of motion simply says that S is equal to ut plus half at square. Now in how much time? It is asking 5 seconds obviously. We have the acceleration? Yes, we have the acceleration. We have the initial velocity? Yes, we already have the initial velocity. That is 5 meter per second. So just put the values here. So 5 into 5 plus half into 1 into 5. Getting my point? Square. Getting my point or not? So 5 into 5 is 25. 25 plus 25 by 2, that is 37.5 meter. So this is the distance traveled by the particle or the car in 5 seconds when the acceleration is 1 meter per second square. Okay. See, they have done this all. So we got the final answer. See, the acceleration of the car is 1 meter per second square and the distance covered is 37.5. Okay. Coming to the next question. A bus starting from rest moves with a uniform acceleration. So here acceleration is given 0.1 meter per second square for 2 minutes. So the acceleration is given for 2 minutes. Let's convert this 2 minutes into second, that is 120 seconds. Okay. It is starting from rest, so here initial velocity is 0. You need to find out the speed acquired and the distance traveled. It is very easy, like very easy. What is the speed acquired? So we need to find out the velocity. V is equal to u plus at, right? The only twist that you need to remember that here the acceleration is given in meter per second square and here the time is given in 2 minutes. So what some of the students do, they just multiply 0.1 into 2 and they get the answer. But that is wrong. Okay. Because here the unit of acceleration is in meter per second square. So time also has to be in seconds. Correct? So just use this equation. This is known as first equation of motion, which relates velocity with the acceleration and time. So here initial velocity is 0. So what do we have here is v is equal to at. Okay, so we don't know, acceleration is 0.1, time is 120. So the final velocity will be 12 meter per second. And when it comes to the distance traveled, so there you can use the another equation of motion, s is equal to ut plus half at square. So s is equal to ut plus half at square. U is 0, so remove this. So s is equal to half into 0.1 into time here is 120 square, right? Okay, so I'll just solve this. Half into 0.1 into 144 into 10 to the power 2. This is how I okay, so this becomes 72 and 1 gone, so 720 meter. Okay, this is 720 meter. Distance traveled by the particle is 720 meter. So let's just check the answers. See, the initial final velocity is 12 meter per second and the distance traveled is 720 meter. Okay, coming to the next question. A racing car has a uniform acceleration. So what we are provided with the uniform acceleration here. What distance will it cover in 10 seconds after the start? So if it is sorry, if it is, we are saying that it is just starting, that means initially the car is at rest, and when initially the car is at rest, so the initial velocity of the car is 0. Okay, we are provided with acceleration 4 meter per second square. What distance will it cover in 10 seconds? Okay, so it is trying to find out the distance. So we'll use this equation, s is equal to ut plus half at square. Ut is again 0. Why? Initial velocity was 0. S is equal to half into 4 into 10 square. Got my point? So this is 2, s is equal to 2 into 100, that is 200. So distance covered by the particle or the car in 10 seconds after the start is 200 meter. Got my point? Just check the answer. Sorry, right? This is the answer, 200 meter. Okay, coming to the next question. The brakes applied to a car produces an acceleration of 6 meter per second square in the opposite direction. So now it is saying that 6 meter per second square in the opposite direction means we have talked about the retardation. I discussed this in the class where I was like discussing most of the theory, right? So what is retardation or negative acceleration? Now they are not mentioning, they are confusing you that okay, we have the acceleration but in the opposite direction. So in the opposite direction means it is the negative acceleration. Getting my point? So retardation or negative acceleration means that the velocity of the car is reducing, it won't increase. So here acceleration is equal to minus 6 meter per second square. Got my point? Minus 6 meter per second square. Now if the car takes 2 seconds, see, final it is stopping. So if it is stopping, that means it was initially moving, but eventually it is stopping. That means the final velocity is 0. And there was some initial velocity which we don't know, obviously, right? So calculate the distance it traveled during the time. So we have to find out distance. Okay, now in this, like we don't know the time, we know the time, right? So what we can do is, what we can find out is initial velocity first. Okay, so in initial velocity, we can simply use v is equal to u plus at, right? A is negative here, so v is equal to u minus at. And if we see that it is finally stopping, that means v is 0. If v is 0, then put 0 here, then equation will be 0 is equal to u minus at, or u is equal to a into t. Now a is how much? 6 meter. What is time given? 2 seconds. So you will come out to be 12 meter per second. Okay. Now you have a choice whether you want to use the first equation, I mean the second equation of motion or third equation of motion, because anyways you have to find out S. So in second equation and third equation you can only find S, no? So I use the second equation of motion here. S is equal to ut plus half at square. Now here the acceleration is negative, so the equation will change from S is equal to ut plus half at square to minus S is equal to ut plus half, I mean S is equal to ut minus half at square. Okay, so just put the values now. S is equal to U is how much? 12 meter per second. So 12 into 2 minus half into 6 into t square, that is 4. Okay, so this is 2, this is 24 minus 12, that is 12 meter. So distance traveled by the car before stopping is 12 meter. Okay, are we clear with this? Now, so the final answer, anyways, it's gonna coming 12 meter per second is the velocity coming, and distance is, see, 12 meter. Okay, this we have already done. Okay, let's go to the last topic, numerical based on circular motion. See, so what do we have here is, it is saying that there is an artificial satellite which is moving in a circular orbit of radius. So this is the radius 42250. Calculated speed if it takes 24 hours. So we have the time also, right, to revolve around the earth. Okay, so look here very carefully. Speed is equal to what? Distance upon time, because the artificial satellite is moving in the circular path, so the distance becomes the circumference of the circle, right? So we can just put the values now. 2 into 22 by 7 into 42250 and divided by 24. Okay, got my point? Right? So when you will solve this, you will get the values, right? Distance upon time 2 by r. See, simple. So they have solved, they have simplified it. So velocity is coming out to be 11 into 21125 upon 21. When you will solve this, you will get the final answer, that is 11065 kilometer per hour. So this is the velocity or the speed of the particle on the this circular path, or the path in which the artificial satellite is revolving. Okay, so I hope that these numericals were very clear to you, and I really want that you should practice all these numericals. I know that some of the questions we already done, like in between the class, but I just wanted to make sure that every topic was covered even after we have done the theory. Okay, so just go through all the lectures. If you find any problem in any of the lecture, just let me know in the comment. Okay, so I hope this motion chapter was clear, right? So till then, you can enjoy, you can study. Okay, bye bye, take care.